All right, hi homeschoolers. We're working on circuits, and today we're going to start with very simple series circuits. Last time you watched a video of the basics and kind of the vocabulary and the way circuits work, and if you hopefully you'll remember that an electrical circuit means that the electricity flows in a loop. So you have a battery or an electrical outlet or whatever, but electricity needs to flow from one end through a resistor, or whatever that resistor is, a refrigerator, a TV, or whatever, in this case a little light bulb, and it has to make its way to the positive end of the battery. So it's electrons flowing through a wire from one end of the battery to the other. And we tried where if you touch both wires to the side of the bulb, it doesn't work. If you touch both wires to the bottom of the bulb, it doesn't work. In order to make it work, you have to touch one end to the side of the bulb and one wire to the bottom of the bulb. It doesn't matter, you can switch that up, but the key is that the electricity is flowing in a circuit, okay? And you can't see inside the bulb there, but if I were to draw the bulb bigger, if it was bigger so you could see it, okay? In order to make it light up, okay, this is the filament, the part that lights up. It doesn't light up if you touch both wires to the side. It doesn't light up if you touch both wires to the bottom. It lights up when you touch one wire to the bottom and one wire to the side. Okay, and that's an important point there, because if you could see inside the bulb, the side and the bottom are separate from one another. They're insulated from one another. The filament, one part of it touches the side and one part of it goes down through and touches the bottom. So when you have electricity coming from a battery, you have a positive end and a negative end. One wire needs to touch the bottom and the other wire needs to touch the side. And that allows electrons to flow in a circuit. So they flow from one end of the battery up through, they move through the resistor, through the filament. It heats up and glows and gives off light, and then the electricity continues to flow and makes its way to the positive end of the battery. Okay, so it has to be a circuit no matter what the resistor is. It has to flow from one end of the battery, or if you're talking about an electrical outlet, okay, you need to have one wire go from the hot side, flow all the way through, and make it back to the neutral side. It still needs to be a circuit. Okay. Now, we're going to talk a little bit about, we'll go over a little bit more about simple series circuits. And series means that the electricity only has one choice. So for a battery or any kind of power source, you have it, this is the way a power source is drawn. You have electricity that flows from one end, like one end of a battery, to the other, and it has to be a complete loop. And what I just did there is I had one light bulb in the circuit. Okay, so the electricity was allowed to flow through the light bulb to get to the other end of the battery, and this is a resistor. And they can certainly get more complicated than that. This is just one resistor, but you can have another resistor, maybe a third resistor, maybe a fourth resistor. But when they're like this, when they are in series, this is a series circuit. And that means the electricity has no choice. The electrons flow out of one end of the battery, and they have to flow through each and every resistor in the series. They have no choice. They have to go through everything to get to the other end of the battery. And an example here would be, we have a bunch of resistors here, and we'll just say this one's resistance is 2 ohms. And we have another one that's 2 ohms, and ohms is the unit of resistance, and we'll say this is a 3 ohm resistor, and this is a, well, we'll make this a 5 ohm resistor. Okay. So we have a 24 volt battery or source of electricity, and it is the voltage is like a pressure. It's pushing the electrons through the resistors. It pushes the electrons through a 2 ohm, another 2 ohm, a 3 ohm, and a 5 ohm to get back to the other end of the battery. Okay. Now, there's a couple of things we need to keep in mind. What we're going to do here is we're going to analyze this circuit. This is a 24 volt battery, and we're going to figure out what the equivalent resistance is. So this battery feels really just one resistance. We need to find out what the total resistance is from all 4 of these resistors. And for series circuits, that's real simple. The total resistance is just the sum of all the resistances in the circuit, okay? And this is for series. So in order to find the total resistance, you just have to add them up as long as they're in series. Next time we'll talk about parallel. But right now, in order to figure out the total equivalent resistance, we just need to add them up. And then we're going to use something called Ohm's law, okay, where the current is equal to the voltage over the resistance. So the amount of electricity flowing through the system is equal to the pressure pushing it through the system divided by the resistance of the system to that flow. And obviously you can rearrange this and solve for V or solve for R. But here, I'll show you how we do this. The best way to do this is to redraw the circuit as though it was in a line. So like break the source in half and draw this as though it were a line. So we're going to break it in half right here, and the electricity is going to flow through the wire and come to a 2 ohm resistor. It's then going to go to another 2 ohm resistor, onto a third, and this one is 3 ohms, and then on through our last resistor, which is 5 ohms, onto the end of the battery. So we've taken it from the circuit loop that it is and just pulled it out, and I know that this is 24 volts, okay? And what we're going to do, since these are all series, we can just combine them all together into one. We can just add them up. So 2 plus 2 is 4, plus 3 is 7, plus 5 is 12. So this is the equivalent of one 12 ohm resistor in our 24 volt system. Okay, so now I know that the voltage is 24 volts, the total voltage. I know that the total resistance is 12 ohms. I can now use Ohm's law to find the total current, how much electricity is actually passing through the system. I equals VR, so I is 24 divided by 12, or 2 amps. Current is measured in amps. And now we want to take that information, what the total voltage, the total resistance, and the total amperage, and we want to figure out what is the resistance, voltage, and current at each and every one of these resistors. Okay, and that's real simple. There's a couple of rules, and for series, it's that the current for series circuits, the current is equal everywhere. That's because as the electrons flow through here, they have no other path. They have to flow through everything. The current is the amount of electrons, and they have no choice. So I know that the current is 2 amps here, 24 divided by 12. That means it's 2 amps here, 2 amps here, 2 amps here, and 2 amps here, because the amount of current has no choice but to flow through everything. So I know that the total voltage is 24. I know the resistance here is 2, and the amperage is 2 amps. Here it's 2 and 2, 3 and 2, 5 and 2. And that now allows me to figure out what the voltage is at each and every one of these. Now that I've backed it up here, I know that I can rearrange Ohm's law to solve for voltage. Voltage is current times resistance. So I can just multiply current times resistance and get that this is 4 volts of the 24, 4 volts are used to push it through this first resistor. And then the second one is still 2 times 2, or 4 volts. So there's 4 volts pushing 2 amps of current through this resistor, 4 volts pushing 2 amps of current through this resistor, and right here voltage is still current times resistance, so it's 2 times 3, or 6 volts. And here it's 2 times 5, or 10 volts. So now I know the voltage, the current, and the resistance at each and every resistor, and I do it by breaking it down to one equivalent resistance, finding the total current, and then working my way back up through. So your task today is to open up this is an example. You have one to do for yourself for homework today. Should take you a little bit. It's different resistors and different voltage, but see if you can't figure out what the total resistance is, the total current, and then work back up and find the voltage at each and every resistor. Thank you.